Hmm. Okay, hello. Good evening, guys. Welcome to our March week 2 class. Yes, hello, Carl. And hello, Andrea. Were you here last week or is this your first time here? Sorry, I couldn't recognize you. Uh, okay, so is this your first day here? And where were we? I think we haven't finished chapter, what was it, 3? Okay, I think we were in 3, right? We were halfway through around here. Oh, okay, so this is your first day here. Okay, we were halfway through chapter 3, so let me finish the exercise first before we jump to chapter 4. Okay, I know you received your chapter 4 already. You should have received your chapter 4 by now, which is the lung chapter. Okay, so Carl, I'm going to finish my biology before I jump to chemistry. Okay, I'm sorry if you need chemistry, but I feel that there's a need to finish biology first. Okay, that's just my thing lah. Okay, I like to finish all first. You need physics first, okay. Why physics though? Why physics though? Okay. Physics, because guys are usually very strong in physics. Usually lah. Okay. Carl, just a question, Carl. Is your school following the Cambridge syllabus? Is it Cambridge? Oh yes, okay. That means okay, we can follow Cambridge syllabus lah. Right. Anyway, so let's look at number 4. Let's look at number 4. So diagram 1 shows hole X on the wall between the two sides of the heart of newborn babies. Normally, this hole closes when the baby grow up. In some babies, it does not close and they need surgery. Okay, remember this thing? This is called the septum. Oh, you were here December, was it? Aiyo, shit, lor. I goldfish memory already. I couldn't remember. Okay, it does serve me a little bit memory here. Yeah, okay, I think I remember. Okay, but only for a month. Well, it was only for a month, is it? Uh, okay. What school are you from again? See if I can remember. What school are you from? Uh, because I've many students come and go, so yeah, sometimes I do forget. Different textbook. Oh, okay, but syllabus should be almost the same lah, right? Right. So Andrew, what school are you from? Anyway, so by the way, guys, this part is called the septum. It's called the septum. Oh, you changed school, is it? Oh, okay. So what school were you from previously? And what school are you in now? So one of the symptoms of this condition is the dark red blood causing the skin and the lips of baby to appear bluish. Explain why the baby appear in such a way. Right, like I said before, the right side of your heart is blue color. Okay, not blue lah, but it's the oxygenated blood. Okay, and then the left side of your heart is oxygenated blood. Okay, blood with oxygen. So if you mix them together, yes, okay, when you mix them together, you don't pump 100% of oxygen to your body. Okay, because usually this part will go to the body and your body will receive 100% of oxygen and it will go back. But now it's a mixture, so it's like 50-50 already, not so pure. Oh, okay, you were previously from 100 lamp. Yeah, okay, now I remember. Now I remember. Oh, okay. Oh, okay, 100 lamp. Then what makes you change your school? Okay. Oh, okay, cool. Oh, was the school not good? Okay, cool. I mean, hopefully your new school is better. So why is it in such a way? Okay, because there's a mixture of oxygenated and deoxygenated blood. Okay. Oh, okay. I see. Right. Hopefully this doesn't happen here, Andre. If you have anything you want to ask, you let me know. But we are currently in chapter 3 lah, so we actually finished this. It's just that some exercise remaining, so I'm gonna finish this and we'll jump for. Oh, okay, okay, okay. Later I'll jump to chapter 4 lah. Hopefully you understand. Okay, so you try to catch on anything if you can. So this blood and this blood they will mix, so there's a mixture of oxygenated and deoxygenated blood. So there will be less oxygen delivered. Okay, let's not say delivered, let's say transported. Sounds better. So less oxygen transported to body cells. Okay, so when you have a lack of oxygen, you will get blue lips. You get blue lips. All right, so that's why when you drown, when your lungs are not working very well, so your lips will turn blue or black. That's a big sign that you're lacking oxygen. So when this baby, he's not very healthy, he or she is not very healthy because there's a mixture of blood. Okay, so we don't want this, because like I said, the right side of the heart is to go to the lungs, and the left side of the heart is to go to the body. We want everything to be separated. You wouldn't want your longkang water and your clean water to mix up, isn't it? That would be very disgusting. So it's the same concept here. Okay, we want everything to on its own. Right, so next B, babies with this kind of problem cannot move around very much. Explain why. Okay, because they lack oxygen or less oxygen transported. You can write the same point too. So when you have less oxygen, you have lower rate of respiration. You get your energy from respiration. So when you have less oxygen, you have less respiration, you get less energy. So you have less energy. Okay, you remember respiration? Glucose plus oxygen, you get carbon dioxide, water, and energy. The process where you get your energy from. So now when you're lagging oxygen, they can't really do this. So you get less energy. So you're very tired. So I think I told you this, babies with a hole in the heart, they cannot run because when they start running, they will start having the fingers will start turning blue. Okay, lacking of oxygen. All right, so next, number 5, identify blood vessel K, L, and M. So K, this is where blood comes in. This is your artery. Okay, artery. As you can see, the wall is very thick. Artery is very, very high blood pressure. Okay, okay. Okay, not really high. Okay, hydrochloric acid, I would say it's high. Good one, Carl. But sodium hydrogen carbonate, I wouldn't say it's very high lah. I would say is around 9. Yeah, that's baking soda basically. That's baking soda. Uh, 10 to 11 really? Okay lah. Then yes, not that strong lah. Not that strong. Okay, so artery, and then your L. Okay, this is your K, L is your blood capillary, and M is your vein. Right? Vein is the less muscle one, less pressure one, and blood capillary is the smallest. Guys, this thing is smaller than your hair. It's thinner than your hair. All right, this is where they do exchange. Okay, this is where they give out oxygen and take in carbon dioxide. You do exchange in the capillary. Like I said, this is your big Taman Road. Oh, sorry, this is your highway, So Shopee delivery, they come here, they come from the highway, then they turn into your house road. You know, the road in front of your house is usually very small, right? That's the capillary. That's how they pass you your parcel. You don't collect your parcel at the highway, do you? You don't, right? So it's from the main highway, they turn to your house, they pass you the parcel, and then they take your rubbish away. Okay, your Shopee in your body has 2 jobs. Is to give you the parcel, oxygen, and to take away your rubbish, carbon dioxide. And then they will go back to the main highway and go back to the heart. Okay, so this is where all the exchange happens because it's really thin. This part is really thin. So draw arrows in the diagram to show the direction of oxygen. Okay, let's use solid line for oxygen. So oxygen is going out to the body tissue. All right, and the direction of carbon dioxide. So carbon dioxide, let's use dotted line. Okay, dotted line here. So oxygen is going to the body tissue. Carbon dioxide is going back to the blood. This thing, they happen at once, same time. They happen at the same time. So this thing is what we call gaseous exchange. Okay, gaseous exchange. And then in the lungs, the reverse happen. In the lungs, the reverse happen, which we will learn next chapter. In the lungs, your blood will get oxygen and throw carbon dioxide. It's the reverse. Okay, it's like your Shopee delivery truck, right? They go to the seller, they collect the parcel, they go to you, they deliver the parcel. You see, it's the reverse. So the same thing happens here. Okay, so see what process takes place at the capillaries. How are the capillaries suited for this process? So what is this process called? What is this process called? Do not write gaseous exchange here. Do not write gaseous exchange here. This process is actually called diffusion. Okay, gaseous exchange is the thing that is happening, but the name of the process is called diffusion. Okay, wow. Where did you find all these facts, Carl? Yeah, the biggest organ should be your skin. Okay, yes, you're correct. The biggest organ should be your skin. Okay, so how are the capillaries suited? Okay, why are we using the capillaries? Why don't we do exchange here or here? Because this is very thin. Okay, your capillary is very thin. In fact, they are so thin, they are very easily injured. Okay, cool, cool. Right, guys, this part will get injured easily. If you bang your head onto the wall, you get a bruise, right? You get a blue black, right? The blue black is when your blood vessels break. So you have a pool of blood here. Under your skin, you have a pool of blood. And they look blue black, 黑青啦, or tan. So that's your bruise when you break your capillaries. So D, provide an example of other substances beside gas that diffuse into structure L from body tissue. So what else comes in here besides carbon dioxide? So you have waste product. Okay, waste product like urea. Okay, urea. Okay, cool, Carol. That's really cool. In fact, I learned something too. Okay, waste product, or you want to say urea also can. You want to say water also can, actually. Right, so E, name the structure. What is this thing called again? This is your valve. Right? So draw an arrow to show the direction of flow of blood. Sorry, there's a typo here. So blood will go through here like this. They cannot turn back because the function of the valve is to stop the blood from flowing back. Because if blood flows back, blood will crash together and you will create a blood clot, which is very dangerous. Okay, so your valve is to stop that. Okay, your valve doesn't allow any of this to happen. So number 3, in which blood vessels can this structure be found? Where can you find this? You find this in your vein. Why? Because vein has all the low pressure. Okay, so you see, when your blood pressure is low, there is higher chance that your blood will go backwards. That's why you need a valve here. There's no need a valve in artery, because the pressure here is so damn high that there is zero chance for blood to turn back. Okay, it's like a very fast river. Water will not flow back. Okay, so that's a valve. So state the function of this structure. This is, like I said just now, to prevent the backflow of blood. Yes, Zihan, hello, good evening. We are in question 5. Okay, the exercise last week. We did not finish this, huh?
Yes.
So we are going to. So F, explain why
Yes.
The blood from ventricles does not flow backwards into the atrium. Why the blood here will not go back here? Because of the valve also lah. Okay, you have valves everywhere to stop blood from flowing back. So because of the presence of valves. Okay, in fact, they have special name for these valves. We call them tricuspid valve and bicuspid valve. But okay, that's not your syllabus. You will learn this in year 10. Okay, just to let you know. Next, number 6, diagram below shows the human circulatory system. So as I said just now, this right side of the heart goes to the lungs to get oxygen, throw carbon dioxide, flows back to the left side of the heart. Then the left side of the heart pumps blood to around the body. This is the capillary. This is where you give oxygen and get carbon dioxide. So you see, it's the reverse. This is me collecting parcel. This is me giving you the parcel, and then come back to the heart. Okay, guys. Cool, huh? Sorry, I'm a bit sleepy today. Very heavy classes today. So, blood vessel P. What is this blood vessel P? The vessel that's going back to the heart is called vena cava. I hope you remember this. And then your Q, the vessel is coming out from the heart. This is called aorta. You need one blood vessel for each room, if you remember. Aorta is your biggest artery in the body. This thing is very muscular and thick. So B, describe how the blood in vessel P is different from the blood in vessel Q. Very good question. You see the color is different. Vessel Q, this place is full of oxygen because it's coming out from the heart. I just went to my lungs and get oxygen. Whereas your P here, I finished giving oxygen to my body cells. So now your blood vessel P has all the carbon dioxide. Okay, so you can say for blood vessel P, it contains deoxygenated blood. Okay, Tara D. Oh wait, why am I writing PM? Sorry. Sorry, force of habit. So Q, that would be your oxygenated blood. Sometimes I write in 3 languages to a point that I get so confused. Why am I writing 3?
I just wanted to see a cool ritual.
Okay, next, C. What is the effect on the blood flow in blood vessel Q when a person is running? Okay, effect on the blood flow when a person is running. Okay, so when you're running, what happens to Q here? You would have higher pressure. Or you can say higher blood flow. Why higher blood flow? When your muscle is using more oxygen, your muscle will tell your brain, hey, bro, I need more blood. And then your brain will say, okay, let me tell the heart. So your brain will go and tell your heart, hey, bro, the body needs more oxygen. Please pump more blood. So your heart will increase. So that's why when you exercise, your heart rate increase because it's going to pump more blood around your body. So you have higher blood flow. Why? Because of the heart is pumping faster. Because you're exercising. Right, so very important, your heart rate will increase as you exercise. Okay. Your heart rate should be around 70 something resting. Okay, when you're resting, heart rate is around 70 something. When you are exercising moderately, it should be around 120 to 130. 170 is when you go all out. 170, 180 is like when you push yourself all out, like you're sprinting away from a dog. Then your heartbeat is a 170, 180. Yeah. Oh, that's cool. That's cool. Yeah, yeah. That's why blood your red blood cell don't just flow like a river, they go whoop, 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 because when your heart goes boom, 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 only your red blood cell goes boom, 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 like that. Yeah, that's true. That's true. So next, your heart is pumping faster. Next, the left and right part of the heart has different thickness. Explain this statement. Oh, we said this before. So your left heart here, your left ventricle has thicker walls. Okay, so right ventricle has thicker wall than left ventricle. I'm just gonna put LV here lah. Y, sorry, I think I got it. Oh, sorry. This is left. Okay, brain fart again. Left side. Okay, left is thicker than wall because you need higher pressure in left ventricle to pump blood around the body. Okay, because left ventricle is to push blood to the body, that's why you need high pressure. You need thick wall. But right is just to go to the lungs. Right? I think we mentioned this. I think we talked about this already. Like you see, this wall here is thicker because this part is pumping blood to the body. Whereas this one is only to the lungs. When I pump blood to the lungs, it's just next to the heart. So I need very small pressure. Okay, whereas this one, it needs high pressure. Oh my God, I'm yawning non-stop. Must be the heavy dinner just now. So number 7, diagram 12.1 shows 2 types of blood vessels. So what is your X? X is your artery. Like I said, this part is under very high pressure. When you chop this thing open, blood will just shoot out like crazy. Okay, guys, if you cut this artery, I think I told you this, if you cut this artery here, blood will spray so hard, the ceiling will be all your blood. That means you die faster too. This one is vein, is very low pressure, so blood just goes very slowly here. So function of vessel X, what is the function of artery? Not all artery carries oxygenated blood. Not all artery carries oxygenated blood. Their job is just to carry blood away from the heart. Okay, out of the heart. Because arrow pointing up, artery. Vein V is your blood going back to your heart. Not going in, not going down. So artery is going out. So function of blood vessel X is to transport blood away from the heart. Okay, wait, why am I writing PM again? Okay, so to transport away, so if I'm exiting the heart, then that's artery. Okay, artery. So it's just happened that most artery has oxygenated blood. Besides one artery, that is your pulmonary artery. Remember? Pulmonary artery is the artery going to the lungs. That's the only artery that carries deoxygenated blood. So the same is true for the reverse. All veins will carry deoxygenated besides pulmonary vein. Pulmonary vein is the only vein that carries oxygenated blood. Okay, so pulmonary, they are reversed. So one difference between blood vessel X and Y, what's their difference? So wall of X is more muscular than Y. Okay, or we say X is more elastic. X has higher pressure, able to stand higher pressure. Okay, so B, an fitness activity has been conducted by 3 individuals. Table 12 shows the heartbeat rate of 3 individuals after the activity. Okay, guys, I did not mention about heartbeat in the lesson last week, but here's the thing, here goes. The lower your heartbeat is, the stronger your heart is. Okay, so why do I mean by that? Why is it so? Because you see, if your heart pumps 80 times per minute compared to a person who needs to pump 40, the 40 guy is stronger, isn't it? Because for that guy, the heart doesn't need to pump so many times. No need to work so hard. Whereas your heart needs to work harder because you're not very fit, baby. Okay, so the better your stamina is, let's say you're a triathlon, then your heart rate will be very low, like super low, maybe 40. Yes, yes. Uh, Nerve cells power our muscle. You are correct. Okay, our muscle uses electric signal. You all got watch Pacific Rim? You all got watch Pacific Rim? They use the robot brain as in you to control the robot lah. Awesome movie. Okay. Anyway, so before activity, the first, second, and third person, they are all 60 something, healthy. After activity, you see 88, 105, and 130. That means this guy is not very fit. You see, his heart needs to pump so many times. Whereas person number one, you see, oh, he's very fit. Even maybe he starts running, his heart rate is only 88. That means, okay, good. His heart is very strong. So why does the third individual have the highest risk of heart disease? Why is he going to have a heart attack or heart disease? Because it has the highest heartbeat or highest heartbeat rate after activity. Okay, highest heartbeat rate. So now you can say that his heart is weaker than 1 and 2. So okay, what makes your heart beat so fast? Number one is being a couch potato, obviously. But to jump this fast usually means you're a smoker. Okay, guys, think about it. Think about it. When you smoke, okay, when you smoke, you reduce oxygen in your lungs. You have less oxygen inside. You have less oxygen in your blood. So what happens to your heart? Your heart needs to pump faster, needs to pump more because your body needs more oxygen. Okay, so it's like a feedback thing. You need oxygen, I pump faster. So if you smoke, you get less oxygen. I will need to pump faster for you. So smoking is a really stupid thing to do. Okay, it spoils your health, spoils your lungs, spoils your heart. And not to mention it makes you poor. Okay, so next, number 8, your blood cells. You have your red blood cells, white blood cells, and you have your platelets. Okay, platelets. This thing is for your blood clotting. Right? I repeat the function. Red blood cell is for oxygen. White blood cell is for fighting infection. Platelets is for your blood clotting. So next, you have your plasma. Plasma. So you have soluble substance and water. Water is like 90% of your plasma. Right? Remember I said your plasma, when you cut yourself not too deep, you see that clear fluid coming out. That is the plasma. Right? Not bad enough that you lose your blood cells, but you still lose fluid. There's a little bit of bleeding there. Yes, it will. Thank you. Yes. Come on outside. Nicotine will also make you addicted. Okay, it will make you addicted. Your nicotine is a lot like caffeine. All right, when you drink coffee, you get addicted. So it's the same thing as when people smoke. So process done in donated blood. You know what, guys? We skip this. But you want to know? I can let you know. This is called centrifuge. Any of you do blood tests before? You hope you can be a doctor. Not in Malaysia, that's all I can say. Right. So when you do your blood test, they will put this into the machine and spin it so that they can separate everything out one by one. Oh, you learn in camp already, is it? So what's the purpose? This is to Separate blood into its component. Okay, to split into three. Why you learn this in chem? I thought this is bio. Oh, centrifugation. Yeah. Centrifugation, yeah. Centrifugation, same thing lah. Okay, you need this machine lah, the centrifuge machine. They have this in all those path lab, all those blood lab. But there's a must in your school. How your school use this for what? Your school use this for what? Oh, separating method. Oh, okay. Wow, you guys have this? That's cool. That's cool. These thing speeds at very high revolution, very high rotation one. Okay, that's how you separate your blood. So number 9, this is the microscopic view of your human blood. Name the type of blood cell that's found. So all these, they are our red blood cells. Okay, and you see all these tiny ones? These are your platelets. And of course, these black ones, these are your white blood cells. Okay, so you put your blood under a microscope. This is how you should see. Okay, as you can see, you do not have a lot of white blood cell. You might say, why, sir? Don't we need to protect ourselves? Yes, we do. But white blood cell is basically like it's like a bomb that is out of control. Right? You see, when you're sick, your white blood cell will just go crazy. They will be on a frenzy, okay, to kill all the microorganisms. Not just that, they also kill your cells. You see, white blood cell, they are freaking crazy one. They will do friendly fire. Okay, you know what a friendly fire is. So that's what they do. So B, compare and contrast between white blood cell and red blood cell. Okay, compare means the similarity. Contrast means difference. So white blood cell and red blood cell, how are they alike? They are both living things. Obviously. Contrast. Okay, you can say red blood cell is for transport. What am I writing here? White blood cell. This is for fighting infection. Okay, so when you get sick, right? If you go and do a blood test, your white blood cell level should spike up. You have a lot of white blood cell to win the war against microorganisms. So C, plasma is also a part of the blood. It contains water and soluble substances. What are the soluble substances present in plasma? So we can say salt. Okay, salt. You can say urea. And so D state the main function of blood to our body. Very easy question. To transport oxygen to body cells. Next, to transport carbon dioxide away from body cells. But that's just a red blood cell. They want a blood. Okay, anyway, you can say carry nutrients our body needs. Yeah, it's the rhinovirus, yeah. Yeah. Actually, you can call it the flu virus lah. Okay, the flu virus is a family lah. Okay, when you say flu virus, people understand. Rhinovirus is not everyone understand. Yeah, acid plus base is salt and water, and that is called neutralization. I think you have learned of that, and I think you have learned electrolysis as well. Sorry, not electrolysis. Neutralization, titration. Okay, I'm sure you have learned that already. Very headache chapter because you have so many types of salt and they all have different color. So number 10, name the component of the blood label P. P is your red blood cell. Function of component P, like I said, to ooh, spot oxygen. Okay, transport oxygen. Okay, this is quite a interesting chapter, quite an easy chapter. So state the effect if a person lacks component Q. Q is leukemia. Wait, oh, Q. Okay, Q is when you have so much red blood cells, they start killing your red blood cell. So that's what leukemia. This is blood cancer lah. So the effect on component Q. Okay, so we can say white blood cell kills Q. That means your red blood cell. Okay, so we can say lack of oxygen around the body. Okay, there's not enough oxygen around because there's no more white blood cell now. That's why leukemia patients, they look very pale. One thing is the weakness, and one more thing is, the lack of, yeah, you know what I mean? Okay, the lack of oxygen. So, number 4, hemoglobin in the blood of a pregnant woman drops to a very low level. The doctor suggests that she eats more meat and grass vegetable. Explain the reason for the explanation. Right, so, hemoglobin is made from protein, and green vegetable gives you some micronutrient. Okay, some things that you need to grow taller. Okay, meat contains protein, which stimulates growth. Okay, yeah, protein, you grow taller. Guys, like I think I told you this before, right? You want to grow taller? Uh, sleep is a friend. Okay, protein is a friend. So why green veggies? Why green veggies? Green vegetables contain iron. You can say for formation of hemoglobin. Okay, so iron is to make hemoglobin. That's why your blood smells like iron. You know, your blood has that irony smell to it. That's the reason lah. That's to make hemoglobin. All right, so that's about it for our chapter 3. Okay, wow, we're finally done. Oh, you want to talk about kwashiorkor. Okay, very easy. Kwashiorkor is when you lack protein. Okay, you lack protein, and your stomach starts swelling because of water retention. That is kwashiorkor. Okay, it's so rare that they have to name it after an African name because it's an African disease. Kwashiorkor. Why, what's up? Kwashiorkor. That's when you don't get enough protein. To what extent that you don't get protein? Usually kwashiorkor happens in Africans, in those very poor African countries, and they are so poor they couldn't even afford flour. Okay, you use flour to make bread, right? They are so poor they can't even afford that, so they get kwashiorkor. Okay, so they have no choice. Okay, that's what life is. Okay, so guys, let's go into our chapter 4, shall we? Okay, respiration. Okay, guys, give me a moment. I need to go to the washroom real quick. Give me 5 minutes. I will be right back. Okay, hello guys, welcome back. Right, so unit 4, respiration. So guys, kindly pay attention. Your respiration and the last chapter, which is your transport, your blood circulatory system, they are very close to each other, right? In fact, they actually do the same thing. Not to do the same thing, but they are part of the same system. All right, so they basically okay, put it this way, they complement each other. That means I help you, you help me. So it's like two pieces of puzzle. Okay, you put them together. So let's talk about respiration. Andre, I hope you have the notes. Because last chapter you were not here. Don't worry, I'll repeat before your exam next time. So respiration, your human respiratory system. This is your 呼吸系统 when you do respiration. Okay, by the way, guys, let us talk about respiration first. Every cell in our body carries out respiration to produce energy. When I say respiration, I mean this. You recognize this? You learn this in year 7. You learn it again now. And next time when you go biology year 10, you'll see this thing all over again. So glucose plus oxygen, you get carbon dioxide, water, and energy. This is what every cell in your body does. Every. Okay? You have trillions of cells, I guess, or more than that, I don't know. Okay, let's just say trillion. You have trillions of cells in the body, and each one of them will do respiration every moment, right? The moment they stop respiration, they die, because this is how you get energy. This is how you get energy, all right? And this thing is actually what we call cellular respiration, right? In short, we just call it respiration. Right? Respiration. So glucose is obtained by breaking down complex carbohydrate and absorbing it through the small intestine in the digestive system. Remember unit 2? Remember your chapter 2? Your chapter 2, you learn this thing. Oh, wow. Yes, you have to give me the chemical formula, Right? Yes, C6H12O6. Okay, wow. That's what you're gonna write in year 10 when you go biology. Okay, yes, thank you. Right, anyway, so you get your glucose from food and you get your oxygen. Okay, oxygen is obtained or carbon dioxide is eliminated. You get this in, you throw this out from the body via our respiratory system. Okay, so respiratory system, that's their job, which is to get your oxygen and throw away carbon dioxide. And the lungs are the main organ of the respiratory system. So you have your lungs here. They are the main organ to do respiration, to do breathing. Okay, I'll go to that later. So our respiratory system carries out breathing to move oxygen in and carbon dioxide out from our lungs. In the lungs, oxygen moves from air into the blood. Carbon dioxide moves from blood into the air. This process is called gaseous exchange. Guys, last chapter, you do the same thing. You do the same thing. At your body cells just now, remember? You throw oxygen, you take carbon dioxide. This is gaseous exchange. Now you're doing the reverse. In your lungs, you're doing the reverse. You are taking in oxygen, you're throwing out carbon dioxide, also gaseous exchange. Okay, so it's basically the reverse. Okay, remember this word, Okay, yes, you see me put a gaseous exchange here. This is a keyword. These gases are carried around our body using the circulatory system, which we have learned, right? So do not confuse these two. Do not confuse these two. Breathing and respiration are often confused, but they are not the same. Breathing is what you are doing physically right now. When you do this, that is breathing. When your cell is doing this, this is called respiration. One is a physical process, one is a chemical process, right? So breathing is just the gaseous exchange, but respiration is the breaking down or oxidation of glucose to produce energy. So it's very different, right? Some people, they call this physical respiration, and they call this cellular respiration, all right? But I just like to call it breathing and respiration, because respiration, there's only one respiration, that's this. That's how your body get energy. Okay, don't get confused, Don't get confused, Next time in year 10 biology, this is very important, When it's breathing, you say breathing. When it's respiration, you say respiration. You don't mix up the two. Okay, so there you go. This is what happens, right? But of course, this is just a simple term, right? To put it simply, your lungs' job is to get oxygen and to throw carbon dioxide. Sounds simple, but let's look at this in detail, right? Any of you learned this before already? Zihan or Andre or Carl, have you guys learned this in school already? Your Oh, you learned it already? Oh, last year. Okay. Huh? Last year. Okay. You mean in year 7? Okay. Your why is the syllabus a bit jumpy around? Oh, you learned last year too. Oh, okay. Is it in details though? Is it in details though? Do you guys learn what is your trachea and bronchus and your bronchioles and your alveolus? Okay. Have you guys learned this? Oh, even came out in exam. Oh, okay, cool. Wow, you guys learned it so quickly, huh? Right, okay, then if that's the case, right, I'm just gonna speed this through, I'm just gonna speed this through. Okay, you can just treat this as a revision. Right. I actually included some extra info in my notes. Okay, maybe you learn something new this time. Right, so guys, let me go through here. Okay, first of all, this is your nose. Okay, this is your nose. And you come down here. Okay, your larynx is your voice box. This has nothing to do with breathing. This is to make you talk. So nothing much here. So you have your trachea here. Okay, some they call it the windpipe. I like to call it the trachea. So trachea, they will branch into two bronchus. Okay, this sounds like branches because they branch into two. So branches, bronchus. So it sounds the same. It branches, bronchus. And then they become smaller some more, and they become bronchial. Okay. Bronchial, eol means small. So bronchial means small bronchus, small branches. Okay, and of course, you have the alveolus lah, but it's not drawn here. So chest wall not important. This is actually a thoracic cavity. Your ribs, okay, ribs are your bones. The whole thing, guys, the whole thing is called rib cage. Okay, the whole row is called rib cage. And then you have your lung, of course. Okay, you know what is the diaphragm? You know what is the diaphragm? You know this thing? I want you to think of this like your syringe. You know your syringe? You know your syringe has a black color rubber inside, right? When you push the rubber, air will go out. So same thing. When your diaphragm pushes up, it pushes air out. Okay? When your diaphragm pulls down, it draws air in, just like your syringe. It's exactly the same thing. Yes, it's like injection. Yeah, exactly. Okay? Trachea close together. Yes, speaking of that, I was just teaching my Form 3 student this just now. Okay, you see this thing? You see this thing here? This is the epiglottis. Yes, 横膈膜. Oh, okay, okay. Wakao, you're from Chinese school, is it? Last time. Okay, so this is your epiglottis. So you remember your esophagus? Remember this thing here? Your esophagus. So your food goes here. When you swallow, food goes here, air goes here. So why won't they ever meet? Why won't your food drop into your lungs? Okay, this one, let me show you something. Let me show you something really cool. Okay, this is how swallowing works. You see, you see the left hand side on your screen? The left hand side, there's a food going down, right? That's the esophagus. And then you see the right hand side, there's like the white color smoke going through. That's your air. So can you see when you swallow, the thing closes? That is your epiglottis, right? So you see how when you swallow, your throat moves up, right? When the throat moves up, it's the epiglottis closing, right? So when you are eating, your epiglottis will always close when you swallow. So your food will never drop into your trachea. Never, right? Never ever. Because if any food drops into your lungs, you can choke, right? You will get choked. So no, not possible. Okay, anyway, so right, you have your lungs here, Okay, so this is your diaphragm. Okay, guys, I have a question here. I have a question here. So your diaphragm is a muscle, right? Your diaphragm is a muscle. You know muscles they cramp, right? You know muscles they cramp. So what happens when your diaphragm cramps? What happens when the diaphragm cramps? It happens time to time, right? And it's not life-threatening. But what do you get when your diaphragm cramps? Something like choking. No, not so serious. Not so serious. It's just a very annoying problem. Okay, see, when your diaphragm twitches, when your diaphragm twitches, like when you have, like when it's cramping, okay, it twitches, you will get, yes, you will get hiccup, like, okay, when you like that, that's when your diaphragm is jumping around, right? So, what are the ways to stop hiccups? Anyone? Anyone? What did your mom tell you to do when you have hiccups? I mean, I've heard plenty lah. Okay, drink water. Drink 12 times. Wow, so specific. Okay, what else? What else? What I've heard is to get scared. Okay, to get scared. Okay, you see how drinking water is very bullshit. Okay, you see, I mean, okay, some of you might say, sir, drink water really works, leh. Because you know why? You know why? Your stomach is here. Okay, your stomach is here. If you fill up your stomach, okay, if you fill up your stomach, this stomach will push on your diaphragm. So this thing hopefully will reset your diaphragm. Hopefully, right? This is how getting scared works lah. If I scare you, you go, okay, you suddenly inhale a lot of air. Hopefully, I will kind of reset this diaphragm lah. Guys, next time, you want to reset your diaphragm, right? Just hold your breath. Just hold your breath and your diaphragm will sort by itself. Okay, so don't need to do all this. 1, 2, 3. 12, man. I heard 7, leh. 12 times, man. Because some of my students they say, sir, my mom say drink water 7 times. Oh. So is it 7 or 12? Do acupuncture. It doesn't work one lah. You know acupuncture is bullshit, right, guys? Acupuncture is bullshit. It's not scientifically proven. Okay, there's zero scientific research that supports the use of acupuncture. But hey, if it makes you feel any better, then go do it lah. Okay, I'm not stopping you. So anyway, air enters our body through the nose. Okay, in fact, to call it better, you can call it nostril. Nostril is your 鼻孔. Okay, your hole here. So we just say nostril, cupping. Okay, lor, if you think it works lah. Right, so enter our lungs through the nose. Hair found in the nose is used to trap foreign particles, dust, bacteria, etc. that may enter our respiratory system. So in your nose, you have all the hair inside to act as a filter. Right? So don't breathe with your mouth, breathe with your nose. Okay, because you have the filter there. So our nose epithelial cell or inner lining produces a sticky fluid called mucus. You know what is mucus? Mucus is your BT, your snot, right? You know how sometimes Okay, you know, when you're having flu, when you're having flu, are there? I think I mentioned it here. Fun fact: when we suffer from flu, our nose lining produce too much mucus. You have too much mucus. This makes breathing difficult and smelling difficult as the mucus is blocking the air passage. Very annoying, isn't it? Very annoying. You know what's the most annoying? You know what's the most annoying? When you're having flu, one side will be completely jammed, one side will be completely free. And then after a few hours, after you messing with the nose, the thing decides to switch side. Now I jam another side, then I free another side. Like, ugh, so annoying, right? So no choice lah, because your body, when you're having flu, it means you have so much virus, so many virus here. So your body is making this mucus, sort of like Spider-Man's web, okay, to catch all the bacteria together, so you don't it's easy for your white blood cell to handle them. Okay, but guys, even you are not having flu, even you are not having flu, you are still producing that mucus because the mucus will moisten your smell receptor. It makes your receptor moist. Okay, makes your receptor moist. This is to enable you to smell. If your receptor is dry, you know what is the receptor? Receptor is the sensor. You know sensor? You know when your dad reverses his car, he has a backup sensor one, right? So you have the same sense. You have a smell sensor inside. So if your sensor is dry, it's impossible for you to smell, right? That's why dry food they don't smell good, but wet food they smell nice. Okay, because you have it dissolves better in your nose. Okay. Epidemic ciliated cell. Oh, you mean epidermal, is it? Epidermal, yeah, it actually does. Right? So, more importantly, helps trap more foreign particle. Wet surface trap more dirt compared to dry surface. So you have your nose hair as the filter, and you have the mucus as the filter as well. Okay, so you have two filters inside. Hey, all the way, guys, all the way, the hair is all the way until inside your lung. The mucus, the same thing. Your whole breathing tract, your whole respiratory tract is moist. Okay, it's moist. The whole thing is wet. To trap the dirt. Okay, so air then enters our trachea, which is our windpipe. Okay, I don't call it windpipe, I just call it the trachea. Okay, and then our trachea is supported by rings of cartilage. Okay, your trachea is actually like this. Can you see the rings here? This is to keep it open, right? This is to keep it open to prevent it from collapsing during breathing. This thing cannot close. If your trachea close for suddenly it closes. Oh my god, you're having a problem because you will suffocate. Right? So your trachea needs to be always open. So they have this cartilage to support it open. Right? This cartilage is actually soft. Right? You know chicken breast? When you eat chicken breast, can you see the white color bone? That is the cartilage. Is tendon and muscle the same? No, they are not. No, they are not. You know this is your bone, right? Okay, if let's say this is your muscle is attached to the bone using a tendon. Right? Okay, put it this way. Muscle pulls on the tendon, tendon pulls on the bone. Make sense? It's like you towing a car. You need to use a string to tow your car, right? Meaning of tendonitis is just tendon swelling. Okay, whenever you see the word itis, it means swelling. Okay, you know tonsillitis, appendicitis, dermatitis. Itis means swollen. Swollen. Anything swollen, we just put the word itis. Bronchitis. Guys, you know bronchitis? When your bronchus is swollen here, you get bronchitis. Maybe due to smoking, or you have asthma, or you are living in a very dusty area, bronchitis lah. Okay, you know what? I'll go into this next week. Guys, I will still proceed this with a normal speed, because just treat it like a revision. Okay, and I hope you can learn something new as well because I added quite a lot of stuff inside here. Okay, so guys, thanks for coming. I will see you again the same time next week. Okay, have a wonderful week ahead. See you soon. All right, you have exam in May. Okay, cool. I'll do a revision for you if I have the time. So, see you guys. Take care. See you. Happy Monday and bye bye. Bye, guys.